Hello everyone. Good evening. I hope I'm audible enough. Can you hear me?
Yes, yeah. Good evening.
Yeah, good evening everyone. Welcome to the ARS Screen Professional Development and Mentorship Program, final cohort of 2026. Today we'll be having our second section in the Tech and AI track, and our trainer for today is Miss Uchechukwu Loretta. Aisha. Loretta is a data professional working across data analytics, data engineering, and educational technology. She's passionate about democratizing knowledge and empowering aspiring data analysts through training, mentorship, and bootcamp instructions. Over the years, she has supported learners from diverse backgrounds, helping them develop practical data skills and launch successful data careers. With a strong background in research and writing, Loretta has published scholarly works and have presented at international conferences. She also contributes to the Federated Engineers as both an engineer and a member of communication team, where she supports technical initiative, promotes knowledge sharing within the community. Her work is driven by commitments to make data education more accessible and creating a continuous opportunity for learning and innovation. Ladies and gentlemen, stand ovation for our trainer tonight, Miss Loretta Uchichukwu. You have the floor.
Okay. Good evening, everyone. Good evening, everyone. Please, you guys respond.
Good
Most
evening.
You're welcome, ma.
thank you. So the class is
You're
very
welcome.
is going to be very interactive. So I hope that we all respond. It's confirmed that you can see my screen. Can you see my screen?
Yes,
Yes.
please.
Okay. Welcome to today's session. Today is a continuation of the last class that we had. And the last class, I know that we've been introduced to a whole lot of things. Is can someone like give me like just a simple breakdown of what was covered? Maybe from your own perspective, what you learned, so that we can build up from there. Anybody? Nobody. What if I tag money to it? Like 5M. Who's going? Jesus. Nobody wants to win the 5M. Patience, but you speak. Patience, so I want the class to be like 1 hour, 30 minutes, or 2 hours max. So we need to speak. You actually need to speak. Who else is going?
Okay. No,
Like what you
I I don't know. What did you decide to do?
a breakdown of what was covered in the last class from your own perspective, what you learned, what you're able to remember.
Okay. What I remembered from there was
Okay, I think this should help you. Does this ring any bell?
okay. Yes. It does. When we talk about the different data collection that we have to do. You told us about how we can structure our questionnaires and unstructured data as well. And we also talked about semi-structured data.
So what is
And
structured data? Example, structured data. After that one, I'll let you go.
okay, in a structured data, these are data that are well outlined. For
Mhm.
instance, now you have the patient date, sex, and in a structured manner that
Mhm.
one will be able to compute at the end of the research.
Okay. So now, this data in front of you, is it structured or not?
Okay, let me zoom it and see. Um, this is not a structured data.
Okay, why? Why? I'll start my own class by 7:15. So it's like a refresher. Why is it not structured? Or why is it structured? Anybody? Is this a structured data or not? Just speak. I can't really see who's raising hand, but you can speak. Anybody can speak.
Okay, good evening. Good evening,
Yeah.
everybody.
Good evening. This is your name?
Okay, my name is Roland Miracle,
Okay.
although known as Mimi.
Okay.
This is a structured data
Okay.
because
Why?
it's being arranged like the way it's appearing in Excel. Like
Mhm.
it's my own understanding, structured data is data that is being arranged in tables or in a spreadsheet.
Okay. So what about this part? Is it structured?
Which one?
This part.
No, this one is not structured.
Okay. Oh yeah, correct. So structured data is arranged in rows and columns. That's like how to identify it. You find it in Excel is what you mostly work with as a data analyst. Unstructured data is usually people that are in this this data is gotten directly from the web, maybe from logs, from websites, the way it is. So data engineers will now like prepare it to be in this structured way that data analysts will now use it to work. Do you get? So this one is structured because it's arranged. That's the structure. It is in rows and it is in columns. But if you look at this part, you see that there's a difference. Everything is inside one cell. Although we are not doing Excel yet, but this is a cell. This is another cell. This is another cell. So it is separated into cells inside each rows and columns. But unstructured or semi-structured, like this one is semi-structured. Everything is like a dictionary nested into each other. No, when you get to Python, you know what's a dictionary. So it is not structured. Then there's unstructured, which comes in videos and audio formats. So that's like what was covered in the last class. I hope that you can go back to your notes if you took notes and like have a refresher. Then I believe that you know what is an integer. You know what is because we are going to be building on the knowledge of the last class. That's what I'm asking. You know what is an integer, right? You know what is a float. Integer is whole number. Float is decimal. Then you know what is string. String is text. Anything that is text is a string, right? Then there's qualitative and quantitative data. So today we're going to be covering this part. Yeah.
So sorry, Loretta.
Okay.
Yeah, so I think quantitative and qualitative data was covered, but integer float was not covered. I think the speaker last class talked a little bit about Boolean, just true and false. That's the only thing he talked about. He did not talk about a float and every and string.
Okay. I'll just touch it. Then we'll now continue from here. So we are covering how data is organized from lesson 3 to lesson 6. So we have three major topics. No, lesson 4 to lesson 6. Data quality, how to know good versus bad data, and how to like work on your bad data to become good. So you can now use it to analyze. Then how to read and understand your data. Then introduction to data analysis. So we'll now go into data analysis proper so that in the next class we'll start talking about tools. So the idea is that whatever we are doing in the introductory class can be applied, the knowledge can be applied to any tool you are using. Whether you end up using Excel to analyze your data, or you use Excel, or you use Python, or you do Power BI, the knowledge that you have here is going to work across the tools because data analysis is more like having the knowledge. The tools is not the problem. You can always learn the tools, but most people don't have the background knowledge. So that's the essence of the introductory class. So I'm going to start with that integer and so you have data types. They are called data types. So data types, right? Here we have data types. data types. So under these data types, there is integer. Integer is anything that is a number. Integer, a whole number. Because when I say anything that is a number, age, if you check your weight, sometimes you see 75.5 is a number, but it's not whole number. So that one that has a decimal is called float. There's integer, which is a whole number, like 250. Age, what's something like that? Identity. Sorry. Okay. So integer, you have 250. It's a number, right? Another example. So you have age. Age can never be in decimal points. If you find age in decimal points, it's a bad data. We're going to talk about it. So age, you know that your age is always going to be a whole number, right? You know that weight can carry decimal. Naira or currency can carry decimal, at least in kobo. So what else? Anything you can think about that is a digit and its whole number, it is an integer. Then when you talk about floats, I already said it has decimal points, like your age, like your height rather, which can be 67.9 for weight kg. When you measure, maybe you went to buy fish, and after measuring the fish, is weighing 2.5 kilo. It's a float, right? Then sometimes then you have string. String is anything that appears in text format. So string, you have string as text format. So text format is like all these things I wrote here. This is a string. This is a string. This is a string. This is a string. You get. Then sometimes you have there's also date time. But in most cases, your date is regarded as string when you are working because you cannot aggregate it. So the idea is that anything that can be aggregated, like summed up, like you can do calculation on anything that cannot be done calculation on is a string. So even though like you have this, maybe you wrote something like this 1, 2, 3, 5, and you're not confused. Is this a string or an integer? It's actually a string because you cannot aggregate this thing. You cannot sum it up. You cannot perform calculations on it directly. So when you're working with when you're doing analysis, most times you will likely format your date type to become a string and not a number. We'll do that. We'll do formatting when we get to Excel and all of that. So this is just what you need to know. There's nothing more to it. Then there's Boolean, just like Jake said, for true or false. When is either you're pregnant or not, right? Sometimes I like to, if he's in statistics, we'll say it's a Bernoulli distribution. There can only be two possible outcomes. It's either it is true or it is false, right? Then instances like you're either alive or you are dead. So just two possible scenarios, true or false. Are you sick? You are sick, true. You're not sick, false. That's just Boolean for you. So you use Boolean also for data cleaning. There are so many places it applies. So that's for data types. We are going to be using them to continue working on what we have for today. Please, if at any point you don't understand what I'm saying, you can ask questions so that we treat it right there. So I believe that we know what is integer now, float and string, right? Right? Where people on this group, right?
Yes.
Yeah.
Yes, please.
Okay, please be responding. I like the class interactive. Okay. All right, so we'll move into what we have for today, data quality. First of all, we have data quality, reading data and introduction to data analysis. We'll start with data quality. Data quality is like how good or bad is the data you're working with. They give you a data set and you look at it and you tell yourself, is this actually a good data or is it bad, right? So how do you identify good data and how do you identify bad data? That's what we want to discuss now. If you identify bad data, what can you do to make it good so you can be able to work with it? Because if you don't do anything to it and you start working on that bad data, the wrong data, you do wrong analysis, and you make wrong decisions. Because you know that computer is garbage in, what garbage out. So you need to like actually work on it to make it good data, so you can do good analysis and then profile good, make the good decisions or profile good solutions, right? So one thing I'm going to do, I don't have slides because I want it to be hands-on and interactive. If you want the formal definition of data quality, you can always Google it. I'm trying to teach you like you don't have to know the definition of everything in your head. Just having an idea, then when you want to work, you can now come and search it on Google. So you can do data quality definition or data analysis. So you just measure of how well a data set meets specific criteria. So we are going to discuss these specific criteria now. So these criteria are what like makes your data either good or bad. So we'll go back there, just like what I said. So now, these are the characteristics of your good data. Is it accurate? Is it complete? Is it consistent? Is it up to date? Are there duplicates? So when you talk about accuracy, you mean the data correctly reflects reality. Like for instance, you know that on a normal day, like in the olden days, yeah, people used to live like 500 years. But the age we are in, if you live like 100 years, you should thank God, right? So when you see age recorded at 250, your mind should tell you that this is probably a typing error, or yes, it's a typographical error, because it cannot be possible that somebody is 250 years and the person typed that thing into there. Even if it's someone that helped to record the data, it's very unlikely that the person is 250 years old. So it's a bad data. It's not accurate. So you need to do something about it. We're going to talk about what you should do. Or you see that, what can I use? The maximum score you should get is 100. And then when your teacher finish scoring, you're having 1,000. Like, it's very wrong. Maybe the person made mistake and added extra zero. So it's not accurate. Then complete, is it complete? A good data has to be complete. Like no important information should be missing. For example, if I come to this data set and you see that all these people have ID. So this ID is like the unique identifier, and all of a sudden, this person does not have ID. It's not complete because I cannot identify who has this particular data, this row. So now it is missing. So it's not complete. Or maybe this person has it, and then his age or the date it was updated is not there. It's definitely not a good data. You need to ask questions about it. It is missing. So that's like what they mean by complete. Is it complete? Then consistent, the same format used throughout. Sometimes when you send out Google Forms to people to fill, and you allow them to write their dates the way they want. Some people write it in this format. Others are going to write it in this format. There are many date formats. Look at my own format. Okay, this format is this one. But there are many formats to write it. Some people use Dash. And then you as data analyst, you cannot work on that data like that. You have to like format it to be consistent throughout. Another example is that when you send out Google form and you ask somebody to feel like their sex, the gender, you see that some people just write M, others write female in capital letter. Some others will start female with F-E, like capital F-E-M-A. Now, in this instance, if it's Excel and you want to work on that data, and there's this thing that will happen to you. So let's say that we have M as maybe here is sex. And then I told you to fill your sex. You decide to write M for me tomorrow. Another person writes for me this one. Another person writes for me this one. Another person writes for me this one. Right? Another person writes for me this one. Now, I want to check how many people are male here. And I want to check how many people are male here. And I do this. And you see that this is what the selection I'm having. So, because there are versions of Excel, as it is going higher, it is able to like detect that this one and this one are the same. But if you're using an older version, you will see different versions of mail there. So because it could not detect that this is actually referring to M, now you're seeing female, male, after M and M, but in reality, these two should be the same. So in this instance, this data is not good. So you need to like format it. Either you want to make everything consistent. In most cases, it's advisable that just make everything lower case, right? So that's for consistency. Then is it up to date? Does it reflect the current situation? A customer address from 5 years ago. That's why they said enter your most recent details. So there are no duplicates, no duplicates. You know that some people like to fill form 2 times just so that they will be sure. Like there's this community I joined and they want to remove people that are not active. And many times they are posted, if you've not filled this form, fill it before they remove you. I filled it the first day. But because they keep posting it every day, I'm tempted to go and fill it again. And if I fill it again, I'm going to have the same details there. So it's meant to be duplicate, you get. And then I know as many people have been tempted to go and do that and do it. Now the person that is going to analyze the data has to fish out the duplicate data and remove it. How will you know the duplicate data? Mostly from their ID. So this one does not have a unique ID. There's always a unique ID, something that uniquely identifies each person. In this case, you can use phone number because in real life, no two persons has phone number, the same phone number. So you can use this as the unique ID. So now when you now check, you now say, oh, this people having the same ID, and now they are the same female, the same age, the same grace. It's definitely one person. So you have to remove one. So you have to make sure that there is no duplicates. So these are the different cases. So we talked about them, right? And then how do you handle this bad data? I partially talked about them in this my explanation. So now, how do you handle it? First of all, you check the data. You like the first thing you do when you open your data set to work is that I'm going to use my eyes to scan it. Like when first time I open this thing, this data set, I use my eyes, I scanned it, I scroll down, I can use my control shift, go down. I'm like, okay, they're actually we stopped in this row 377, like visual inspection. Just as you're inspecting it, so many things are going to come to your mind, and that's what's the first instinct that you're going to work with. So when you finish checking the data, then okay, then as you're checking it, you're identifying missing values, you're identifying outliers. So I didn't talk about outliers. Is it present? Okay, let's talk about outliers. You're identifying outliers. You're seeing duplicates, you're seeing inconsistent categories. Inconsistent categories is what I showed you about date format or writing mail, like your gender in different ways. Then you have to now work on it. So before we do an example, because we're going to do an example, after doing the example, I write down that one for somebody to help us to work on it. So outliers, right? We know what is missing value. Missing value is when a data is missing, a data point. Like here, this the phone number of this person is missing. That's the missing value. Then for outlier, so we do outlier. So now when I say outlier, I don't mean the outlier AI that's raining now. Outlier is like a data point that is so different from other data points. That's the simplest definition of it. At this point of data analysis, you work with the most basic of it. But if you're doing data science, and you're working with large data sets, you use more advanced method to identify outlier. I used unsupervised machine learning method during my undergraduate days to work on outlier for my project. But we're not going to be doing that as a data analyst. We'll just handle it in the most simplest format that we're going to talk about now. So, like I said, let's say you have this. You have 12, you have 13, 14, you have 16, you have 18, and all of a sudden you have 999. So in this place now, 999 is an outlier because this data point is very different from others. If you look at others, there's almost a sequence. There's always almost a sequence here. And all of a sudden, out of the blues, you're seeing 999. Now there are many ways you could have done this thing. Some people will say after all, 999 is in a number. Let me work on it like that. Now, outlier is not always a bad data. Outlier is not always a bad data because if I am having low sales and then we started doing campaign advertisement, and then the next month the revenue that we generated skyrockets, I cannot say it's a bad data. It's a good data in that point. So that's why we need to talk about how do you handle outliers. It's not all outliers that are bad. But how, first of all, you need to know what an outlier is. So outlier is any data point that is so different from the rest of the other data points. It's just like when we were teaching a child apple, a ball. They're talking about fruits, and all of a sudden you mention an animal. That animal is an outlier in that section. Apple, banana, orange, and then you see lion. Lion is an outlier. Or you have a set of colors, primary colors, and all of a sudden you're seeing secondary color. Secondary color is an outlier. So anything can be an outlier, it does not have to be number. So far it is different from the measured data points you're working with, it's an outlier. So for numerical, for when you're dealing with numbers, that's quantitative data. This is a quantitative data because they are numbers. When you're dealing with the quantitative data, how do you handle outliers? So what you need to do is, first of all, you need to ask questions. Hey, maybe ask the person that sent you that data. I saw this number that is so different from others. Is there any reason why it is there? So people discuss. Now, let's say that as you're working with this data, somebody needs his age. This is the missing value now, right? And there's an outlier here. So you're dealing with two things. Is either you need to work on this missing value, and you also need to work on this outlier. So how do you do it? So what I will do in this case, I'll say, after discussing with the person, and I find out that this is an error that is not deliberate, and I need to work on it. Then the next thing I'm going to do is that I'm going to like calculate the check for the median. Some people make the mistake of using mean. Now there's an error when you use the mean of this value to get the missing data. Because for missing data, you have to replace it with something. You have to estimate it. First of all, if you have missing values, it is either you remove all of them if there are very few. And let me take it from here. Let's say that here, I want to use numbers. Let's say that here, this is missing. Here, this is missing. Here, this is missing. Then, because out of this whole data set, let's say that there are 10 missing value or 5. I know that when I remove the rows corresponding to these missing values, it's not going to affect my data set much. I would remove it because there are very few. Because there are very few, you remove the rows. Now, if they are much, you now start thinking, I cannot remove. Imagine you have 500 data like rows, and then you end up deleting like 300 because those 300 rows have like missing values at some point, and then you work with 200. That's like very bad of you as an analyst. So if the missing values are like much, you have to now think of another alternative that is not removing them. So that alternative is you have to now estimate. So how do you estimate? Do you use median? Do you use mode? Or do you use mean? So now, how do you estimate? In this case, if I'm working with numerical value, I'm going to use median. Why? Let's do some experiments. I will duplicate this. I will duplicate this. I'll put it here. I'll just use a more simple number 1, 2. Missing. So we are trying to like handle this missing value, right? Bearing in mind that there is an outlier here. So because there's an outlier, I'm going to use median. But if there is no outlier, assuming that hello mommy. Guys, I'm in my class. So if there are no outliers, you have to like do an estimate, right? And you have to use the mean if there are no outliers. I think I should write these things down so you can make this smaller. That it doesn't confuse us or people that would uh missing values. Missing values. Number one, no outlier, right? If there is no outlier, what do? You use your mean. True, there is outlier. Use median. Three, it is a textual data, qualitative data. Qualitative data. You use bold, right? So now let's do an example, one after the other. You don't get confused. I'll still duplicate this. Then for the first one where there is no outlier, this is it. So no need. First one where there's no outlier, how do you work on it now? So I'll work on it. Since there's no outlier, we use mean. So I'll just add up. So how do you, I don't know if we know how to calculate mean or sometimes called average. So you just add 1, 2, 3, 4. So 1 plus 2 is 3, right? 3 plus 3 is 6. 6 plus 4 is 10. So 10 divided by 4, we have 2.5. So I'm going to replace this with 2.5. So that becomes our. So now, anywhere you see missing value at that point, you can use 2.5 because I don't have outlier. Now, assuming I have an outlier, I'll duplicate this, and then there's missing value here, and then under here, I have like 100, which is an outlier. Let's see what happens when you use an outlier. When you use mean for handling missing values, when there is an outlier. So what would happen? Initially, we calculated 10, right? And then plus 100 to give us 110. 110 divided by 5 is going to give us what? It's going to give us 25, if I'm correct. So now, you would see that, assuming that these are like age or no, or scores, they are saying that the average age of a person in your data set is 25, which is very, very wrong. Because if you check 1, 2, 3, 4, the values are way below that 25. So when you use mean to estimate your missing values, it's going to skew it to the right. Like it's going to extend the number way beyond what you have in actual data. So that's why you should not use mean. Now, assuming that this number is also like below, let's say I use 0.001, it's going to bring it down to a digit that is so far away. Because in reality, mean means that relatively everything here is around 2.5. 1 is so close to 2.5, 2 is close to 2.5, 3 is close to 2.5, 4 is close to 2.5. But now that there's an outlier of 100 and I'm using the same mean, I'm saying that I'm telling somebody that does not see my data set that the ages in my data set are revolving around 25, which is wrong because when the person comes to your data set, they'll see that your data set is 1, 2, 3, 4, that they are below 25 by far. So it becomes a wrong decision or a wrong insight that you're giving the person. So that's why when there's an outlier, you don't use your mean, you use median. So now, if we are to use median, it's just arrange this thing in ascending or descending order. So now we have 1, 2, it's arranged. So median is like the middle number. So now, the middle number is going to be what? You have these two will go, these two will go. So the middle number is 3. So you see that it's very close. 3 and 2.5 are also very close. So you are still within the range of your data set. So that is why the rule of thumb is that if you have an outlier in your data set and you need to work on a missing value, use the median. If there is no mean, if there is no outlier, and you need to like settle missing values, because surely there will be missing values. Yeah, you need to settle them, use mean, right? Then if you have textual data, in that case, you can use your mode. I think I have example here.
Sorry, please, I have a question.
Okay.
Okay, concerning the one that you say if there's an outlier, then we use we're not replacing because there was a gap there before the 3, and then
Yes.
you arranged the values. So does it mean that
Mhm.
you're not replacing it with there's not going to be additional 3? Because I was
Okay.
thinking maybe after arranging it, maybe since 3 was the middle or something.
Yes.
Yeah, I thought there was going to be another 3 there or something.
Yes, there is. There is. So what we did is to replace that missing value with 3. So assuming there's
Okay,
also missing value here, to replace with 3. Or there's a missing value here to replace with 3. Do you get
okay,
it?
yes, yes, thank you.
All right. So,
Okay, please, I have another question, please, if you don't mind.
all right.
Okay, you talked about the outliers, that when you have outliers, you're supposed to remove it, if I understood what you said. So in this case, like if you look at the data and the outliers are probably a mistake or it's not in line with the way the data should flow. So when you're now trying to sort out these missing values, is it advisable to remove the outlier before? Because had it been we remove the outlier here, our median won't be 3 again. It will not be between 2 and 3. So my question is that do we remove outliers before we try to fill the missing values? Thank you.
No, you don't remove the outliers because you are deleting important data sets. Remember, I said not all outliers are bad. So the thing is that you don't delete data points anyhow because each point is sending a message. So that is why you have to work around it, use mean. Not remove it because now maybe there is 999 here, and then there is still like 1000, and there's still like 300. So now you want to now remove everybody's data points. So that's why I said the first thing you need to do is you have to speak with the people that owns that data set. Okay, I noticed that there are a few data points that are not so different from the rest of the other data points. And I would like us to discuss whether you think this is a typographical error and should be corrected. You can easily correct it if they are very few. Now, if the person said, oh no, I don't really know what happened here, and there are missing values for you to work with, you can now use our main to fill your missing values. So the point is that number one, you don't delete data points anyhow. You need to give the person first. Then find your way to use calculations that we did to fill your missing values if there are any.
All right, thank you, ma'am.
Okay. So now if we are to represent this in a chart, it will still tell us that, oh, this person is 1000, this person is 300. And maybe there are many, for example, people with their age, there's 12, again, there's 14, there's 16, and there's 12. And you use the chart to represent this. The chart is going to tell us that two people are 12. I think 3 people are 12, 2 people are 16, 14. And then there's just one person that is 999. So obviously anybody that's looking at it already knows that 999 is an outlier. So that's how you work with it. So we have this simple example. We've already talked about main, median, mode. Mode is most occurring number. Like here, remember what we said that strings or qualitative data are, are in text format, right? So now you have product sizes, maybe bought clothes, some as small, medium, large, medium. So now you want to check, and there's a missing value, and you want to like work on that missing value. So what you do is the merge, because in this case you cannot add small, medium, large. You can't add them to get a mean or a median. So the only way you can work on it is to use the most occurring one, which is M, right? So M would be used to replace our missing value here if there is M. So I think we are done with this part. So let's take a look at our guide. We know whether we are on track. Okay. So I think that's we covered this too. So the next thing is choosing your chart, then correlation and position. So before I go into choosing your chart, let's talk about correlation and position, because you will hear it a lot in data analysis, especially if you are going to be analyzing academic works or paper. And then people tend to like mistake or confuse correlation with position. So the rule of thumb is that correlation is not causation. So correlation is not causation. They are two different things. Causation is not correlation. Correlation is not causation. They are different things. So let's take them one by one. And then we use example to understand them. So when you talk about correlation, you say just like this place on here, relation, that's like relationship. Two things are related, right? For instance, the sun is too much, and you see people buying ice cream, and then you see people selling off their cold sachet water or bottled water fast fast. So those people that would sell those things at that point are going to make like very rich sales. So at that point now, high intake of ice cream, high sales of pure water, they are correlated. But it does not mean that having high intake of ice cream will cause somebody, because a seller who is selling what's it called, the bottled water, to have high sales. They have a relationship, yes. As this person is, as people are taking more ice cream, which is true. People are taking people are selling out their water, cold water, because at that point the weather is hot, which is true. Now they are related. And another example is that, let's say I spend 1 hour to study, I got 40. I spent 2 hours to study, I got 60. I spent 3 hours to study, I got 70 or 80. Now there's a positive correlation between my study hours and the result I get. But it does not mean, like, it is not a proven fact that if I study for 6 hours tomorrow, I'm going to get 100, because correlation is not similar causation. So now what you need to do, correlation tells you that, oh, I think there's a relationship here. But you cannot stop there. You need to think further. What is the cause? Oh, I think there's a relationship between when I study for longer hours, I get more results. But I need to like go further. Is it true? So it's time investigating. That's when you now find the cause. So let's go back to the ice cream and the water bottle. So people are taking ice cream, then people are buying water, then people are swimming, then people are drowning, right? Like all of them are on the high side. So you now start asking yourself, I think there's relationship here. That's a correlation. But then what is the cause? Like, what's the cause? Is it because the sun is too hot that people are buying too much ice cream? And then they're buying water. And then the sun, because the sun is hot, yes, so they tend to swim. And then because many people are swimming and maybe most of them don't know how to swim, they will drown. So you now say that the cause is that hot weather. That's like on the top. So let's break it down further. This one here. So this is like what I'm trying to explain. There's hot weather, which is the cause of it all. And when there's hot weather, like if you've been to camp, there's this man that will tell you that if you're not sweating, you're wrong. Like what he means, he sells ice cream. So that's like his adverts. Once you hear it, you know that the ice cream man is coming. Because the sun is too much. And people will lick ice cream. Like people will buy ice cream to take. So he would say if you're not sweating, you're wrong. That means you have to sweat because so that you can buy his ice cream. So that's like the cause, the hot weather. Now, most of other persons are swimming, and then because they swim, so drowning cases, the cause is now high swimming rates, right? And then the cause of high swimming rates is now hot weather. But these two, high ice cream sales does not cause high swimming. That's the difference I'm trying to make. High ice cream sales does not cause high swimming. But there's a relationship at that particular time that people are selling more and people are swimming more. So what is down the cause? Did you not investigate further and you see that it is hot weather? What I'm trying to say is that people will give you their data sets to work on. And then because you think there's a relationship, you're not going to conclude that high ice cream sales is the cause of people swimming at a very high rate at that point. And then you go and tell your research or tell the stakeholders that let's start selling ice cream more. That if you start selling ice cream more, people will swim more. And then they implement that your plan and then they lose their money. So that's why you need to learn that correlation is not causation. But if you told the stakeholders, I observed something. I observed that at what are the months that are dry season in Nigeria? I don't cry that from my head. But let's say that it's in June. And you say, I observed that in June, the weather used to be so hot, like the sun is so scorching that. So, I observed that in June that people used to take ice cream very well. Like when we put out ice cream for sales, we sell out. Our swimming pool, we get people that book it. So we need to find that this is a relationship I found out. Then you now start asking yourself, why is it so? Why is it so? Because in November it's not so. So what's now the case? So you now start thinking, yes, okay, I think it's because the weather is hot. So it means that in June, we should produce more ice cream and we should make sure that our swimming pools, like if we can even build like 3, or I don't know how they would do it in terms of swimming pool. But for ice cream, let's produce more ice cream that is going to sell out. But in cases like months like November, we have to reduce our hand in the way we produce ice cream and the way we sell cold, chilled bottled water because it's raining and people will not buy much. Now you know the cause, so you can profile the right advice, make the right decisions. So I think I've explained this part. I'll tell you to test us. Let's see. What do you need? Still the same thing. Okay, I want to ask a question. So that somebody will explain for us because we are right, like our time is okay. We are at the right timing. So let's ask it questions on what we've done so far so that Patience will answer for us again. Patience, are you ready? Is she here?
Yes, I'm here, ma.
Okay. Don't worry. You're with me on this journey. Okay. So let's pick a question, a scenario where we say instead of having 1 hour, we have okay. I'm trying to look for a very realistic example as possible that everybody can relate to. Let's say people that are doing 17 courses in school. So they're doing 17 courses in school, right? And then at the end, you get 8th position. Then somebody else is doing 9 courses. The person gets 5th. 9. Person gets 5th. Then this person gets first. But he's studying 3 courses. Change the hours to courses in your mind. Then this person is third. So now, what pattern do you observe? Once you look at this thing now, what pattern do you observe? Anybody?
I observe that the cumulative for each of these courses will not be the same. That is why this other person that has 17 courses took 8th position, and the one that has 9 courses took 5th position. So what I notice here is that the cumulative for each of these courses are not the same. Hence the difference in the positions.
Okay, that's a very good attempt. Well, there's something I want to hear. Anybody?
Yes,
Anybody else?
yes,
What questions was that
was
you?
me.
Okay, somebody else.
Okay, I think I observed that it seems like the higher the number of courses the person attends, the you know the lower, as in like maybe the more courses, the position of the person increases. Like now, it has 17 courses, it came 8, but the guy that has the fewest course, the one that has 3 courses, he has the first position. So like the less he has to do, the more he comes up in the position rank.
Okay, yeah, that was a better way to put it. To put what patient has said. Both of you want to say the same thing. Oh, it's a better way to put it. So I observed that when I have 17 courses, I'll take 8th position. If I have 3 courses, I'll take first. I have 4 courses, I'll take third. So now, the relationship there is more courses, lesser performance. So can we say that um more courses is the cause of lesser performance? Like, how do we like prove it? So that's when you now start like experimenting more. Maybe so what you will now do is you say, since I've noticed this trend, in the next what is it called? In the next term, what I will do is that I will assign these students the same number of courses under the same condition. Because now there are unforeseen circumstances here that we might not know about that might be influencing this. It is either that now this person that is taking 17 courses, he is not serious, he does not read his book, or he does not have a lesson teacher at home, or there are so many hidden factors that could cause the relationship, that could make the relationship to be there. So that's why you need to go further. So now the person will not say, that's why you hear in mass. What's that mass that they say that the same circumstance? I'm trying to remember, I cannot remember the topic. But there's this thing that say under the same circumstance, this and this. So you subject them under the same circumstance that these people, all of you, there's no extracurricular extramural lessons for anybody. You come to class exactly at 8 a.m. and you leave. So you can now watch it very well so that you would know if actually more courses are really going to give you less performance. So it is after your investigation that you can conclude that, okay, the higher people study more courses, the, the workload is going to be much on them. And if the workload is much on them, now they are likely to perform low, like perform badly. So the essence of the whole thing is that when you look at a data set, first thing your mind see is a pattern. That pattern is a relationship. It's going to either be a positive relationship or it's going to be bad. In this our case for courses now, it is bad because the higher the courses, the lesser the performance of the students. Then when you notice these things, you have to experiment. That's why people have experiments. That's why they share questionnaires. There's maybe somebody did a study on HIV/AIDS and they found out that people with high viral load tend to like go into the stage of AIDS because if your case is just HIV and you have non-detectable, like your viral load is non-detectable, there's a case of you living a healthier life. So people they have noticed these things, but to prove it, people will do studies and they'll do experiments. That is when they now go to hospitals, start collecting sample data of many people so that they will not just conclude based on the single observation that they had. After that, they can now conclude, okay, this causes this. To avoid this, do this. To avoid this, don't do this. So that is that for us. Any questions on causes, on correlation and causation? So in most cases, causation is not what correlation, but there are situations where you would see the both at the same time. Do you have any questions there before we go into another thing? Talk about charts.
But please, I have a question.
Okay.
Okay, I assume that at this point we're already analyzing.
Okay.
So if you already have this data set and you're
Mhm.
seeing this relationship and you don't have enough data, to be able to say, is there a causative relationship, because all you're seeing is the positive or negative relationship. So at this point, is it safe to just mention the relationship and leave it there? Or do you need to maybe get to the field again to now be able to prove if there's a cause and effect relationship?
Okay. So assuming this is a data type, somebody gave me this data. Let me say I'm working for a company. So now that's where you have dashboard at the end where you share your findings. And then in the dashboard, it's not just going to be charts. There's also a space for you to like write things down. So you are going to tell them explicitly that there's a relationship here, right? Because if you're working for a company, I'm using a company because uh I'm using company. Okay, I'm still going to do academic research. So if you're working for a company, you tell them that, okay, I analyzed the data and I saw that there's a relationship between this and this, and we need to look into it further so that we would, because the truth is that that company cannot work on that just one single report. Maybe, for instance, now like the place I am, you do there's a weekly report. So you have noticed that thing on Monday, you notice it on Tuesday, you notice it on Thursday, like for the whole days of the week, you notice these relationships. I think that's consecutive relationships, and at every point, they are pointing to the same thing. You cannot conclude that this is the cause because you've done it over time, investigated. You've not just worked with one and then concluded. That's for maybe a company data. Then, if it's for field, for somebody to be doing a research, that person has noticed that thing before they start collecting data. I collected data for what was that? Patient satisfaction in HIV clinic. That doctor that is doing that analysis, why did she start it? Because she has heard murmurings. Patients will complain. Doctor is come late. That's when we go and we should sit down for long hours. So now she has seen the relationship that doctor's coming late. related to patients staying longer hours in the clinic. Sometimes they won't even get their drugs, wasted transportation, and in the end, they are not satisfied. Although it is not like a written or a documented data that is in a database, so she don't have any evidence to prove it. That's why she will now collect data in the field. So even in the initial, there's something that has triggered that relationship for them to start working on it. It's either it is documented and the data is in a database, or it's something you observed like around, and then you decided to investigate it further. I don't know if I answered the question.
Yes, ma'am.
Please, I just say yes. Uche. Yes. We are learning together. Okay. So now, the next thing is charts. So I mentioned dashboard. I'm going to So on LinkedIn, I'm going to see, but I don't want to enter LinkedIn. So we have this. Exactly. So you must have seen these things. Let's say I'm looking for the one that has the most common chat types. So paste. Okay, this could work. Yeah. But I'll just image. So we use this as an example, right? When you look at this dashboard, so this is what I mean by dashboard. There are a lot of things going on here. It's not clear enough, else I would have used it, like we'd have seen the point, but it's clear enough for us to demonstrate what we want to demonstrate. By the way, this dashboard, you can create it with Excel. Then, so now the chart types, if you look here, there are different chart types. There is this is called a pie chart. This is a pie chart. This is a map for geographical locations. This is a bar chart. This is also a bar chart. But this is column bar chart, and this is horizontal. I'm going to talk about them. Then this is a line chart. This is also a line chart. Then these are your KPIs here and here. So we're going to pick them one after the other. So if you are doing analysis, you know that human beings, they are visually wired. It is easier for us to remember things when it's in picture format than when they are written down. It's not even worse for Nigerians because Nigerians don't like to read. So the way, then for your stakeholders that don't have the whole time, I think that's the most part like about dashboarding. Your stakeholders, like if you are doing presentation in a meeting, they don't have the whole time to come and start reading the write-up. Maybe you wrote about it on the journal. So you can use the dashboard to show a snapshot of everything you've worked on. Now, this dashboard is very tricky because nobody knows the kind of hard work you have put before this you got to this point. First of all, you have cleaned your data, like formatted and did everything. When you get data cleaned, then you did everything. Even to get this dashboard to be beautiful like this is another work, but nobody cares because maybe that's what of course, that's what they're paying you for, right? So you need to know which chart type should I use at which point so that you don't use the wrong chart type for another thing. So that's what we want to talk about. Now there are four major chart types. Then I'll use map to make it fit because there's map here. For Excel, the lower versions of Excel might not have map, but if you're using from 2013, 2015, it's likely see map. I'm not sure about that 2013, but 2015 from yes. So now you have the chart types, right? So this is called a pie chart. When you use a pie chart, you want to use a pie chart when you want to show different parts of a whole. let's say that I'm working in telecom communication company, and in that telecom communication company, we used to handle airtime, Airtel, we used to handle MTN, we used to handle Glo, we used to handle there are four networks, Airtel, MTN, Glo, and okay, Nine Mobile. Let me just put Nine Mobile. So now I want to know the percentage of users in each network. That's number one thing. So all of them has to aggregate to total of 100. They are one whole. The most simple example is in primary school is that cut an orange, then you share the parts of it. Somebody takes 1/3 of it. The other person takes 2/3 of it. The other person will take 1/3. Then the remaining people share the remaining ones. So that's like a pie chart. So now pie chart is usually represented in percentage. I'm trying to zoom it out so that you can see that this value is here have percent in there. Right? They have percent in them. Now pie chart has a rule. It must not exceed 5. At most 5. There's this book I'm going to recommend. Data storytelling. I don't know this. I don't know the other name, but I think by Nicole. Sorry, can you see my screen? Can anybody hear me? Because I'm seeing that I'm having poor
Yes,
network.
we are
Yes,
seeing your screen. We are hearing
I
you.
can hear you and I can see your screen.
Okay. So I'm trying to like check out the name. But I still want to remember the last name of the author because the name is hard to pronounce. So his last name start or her last name start with S. Share something. SCH. So if you see it, you know. So the book, there's a chapter in that book that talks about your dash like charts, and you would see every breakdown and rules that should apply to charts. So one of them is that you don't want your pie chart to be so congested. If it passes 5 things that you want to represent on a pie chart, please use a bar chart for it. Like bar chart is this thing. You can see that it accumulated a whole lot of things and you are still able to read it. If you use many things to represent a pie chart, it will break into so tiny pieces that you cannot read the data. And you remember your aim is that somebody can take a look at your dashboard and have an idea of what you are doing. So you need it to be as clear as possible. So if you have like these people now, they have 1, 2, 3, 4, 5. This one is 3. If we check other images that we have about pie charts, you would see that pie chart is not going to be more than 3. This one is actually wrong. But let's see this one for example. So you know that to be it. Okay, let's go there. Sorry. I'm just trying to like make this whole thing as practical as possible. That's why they're doing this test. This one we used. Okay. 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 See what to make. See what to okay. So let's try this one. Okay. So to know waste our time, I think we'll get to know it like better when we start doing dashboard. But just know that the rule of thumb, if you put 5 and if you put 6 and you think you can read it, fine. But please just be mindful that when you're representing a data set in a pie chart, you don't want the lines to become so tiny that somebody has to struggle to read the percentages or the data points that consist that pie chart. That's number one. Then number two is that the percentages has to tally to 100 because it's 360, like it's 100%. So you don't want to have 101 at the end of your after adding the percentages, right? Same thing with here. Even if it is 2, you need to be sure that when you add the percentage of this, they are 100. So that's the rule of thumb for pie charts. Now, we've talked about when you use it. Yeah, you use it when you're trying to do what represents the components of one thing. Now, we go to bar charts. So bar chart is this. Like I said, we have column bar chart and horizontal bar chart. So this is column. You know, column is vertical, so that's why they call it column bar chart. And then when it's here, horizontal is vertical. Horizontal, that is slanted like this. So the difference between these two things, they are doing the same thing and they are using the same scenario. But the difference is that if you have data set that their descriptions are very long, and you know that shortening it is going to distort the data, use a column, use this type so that you can see that here the names are more spread out, right? And then if they are also much in number, column can help you to show it in a more clearer way. Not column, this horizontal. Then for column, you have this type. Very few, the names are short, right? So that's for column. So when do you use a bar chart? Use a bar chart when you're trying to show comparisons between two things. Let's go back to our where we are. So now we've talked about this one. Who can tell me this market share? Where does it fall under? Or let me reserve the question for later. So for comparison, use a bar chart. I have different products and I have the number of users. Let's say, for instance, Dangote. You know, Dangote is into cement, he's into sugar, he's into. Then he wants to have a visual comparison of the different products that he's selling. So he will have this bar chart that shows that, okay, 40 people bought a cement, 100 people bought sugar. So it's just like you want to visually compare things. Or for instance, I'm selling skincare products and I want to know which of the products that people are actually buying the most. Maybe product A or product B or product C. So, and their data is there. So what I'll just do, I'll represent them in the bar chart. Looking at that bar chart, the higher length will show you that it is the one that people buy is the most, right? Then you have line charts. Line charts, use it for whenever there is time. You want to show how people buy umbrella within the month of June. Now, June is a month, it's a timeline. So you use a line chart. Let's go here. This is a line chart. So now, if I want to interpret this, I can see that sales were really low at the start, then it went up, and then it was a bit static, like not static. If it was static, it's a straight line like this, but it was not moving fast. And then there's a dip in at this point. Maybe this point is June, and then it went up again around July. And so it's not restricted to just because now you will see these people using these people that are into stock market using these line charts a lot to know when the sales is high and when it's low so that they can invest or not. So far it deals with time. It is time bound. You want to check what is happening within a time frame, you can use your line chart. Maybe you want to check hourly rates of consumption, you can use your line chart so that it will show you that by 12 a.m. people order Uber the most because they are 12 a.m. people don't order Uber because most people are sleeping. The way is around 5, people are going to work. The order. Then in the weekend now, you now have from Friday to Monday to Saturday. So maybe this is Monday, it is very low. Then when it gets to Friday, there's a spike up. So that it is weekend, people are going to party, celebrations, so they order Uber more. And the line will show you that it went up, like from here to here now, went up, meaning that there's kind of more order at that point. Then on Sunday or Monday morning to now decline, people have stopped going to party. So that's like how to read the line chart. When it is static, like here, it was static at this point. If you did physics, you will know the velocity time graph. That how to read it. So the static. Then there is another chart that is called your scatter plot. Scatter plot is not here, but let's try to draw it. So I'm looking for this. And I'm trying to this is my X and Y axis. And then probably this is our point 0, right? So we have 1 here. Then over here, we still have 2. Let's just stop at 2. So here we have 40 or 20. And here we have 40 here. Sorry. So just know that this 40. Right? So now, if I'm to plot this, maybe I said when it's 1, it's here. Then when, like what we did, the hours of study, it is in, the person got 20. Then when the person studied for 2 hours, person got 40. So this is like the scatter plot. It shows correlation. It is used to represent correlation in a data set. So if you want to show somebody whether there's a correlation or not, whether it is a positive correlation or a negative correlation, the best chart to use is your scatter plot. So now at this point, if I have so many of them, maybe this one went up here. Then this one again came here. So now you're trying to tell somebody a message that, okay, when it was 1, maybe it's 0. When it was 1.5, it's increased to this. When it was this. So basically showing the relationship. Then the final one is the map. So that map is of course, very easy for us to know that map is for geographical location. If you want to like tell people that, okay, these are the geographical areas that we covered in this bootcamp, say that ARSPN wants to showcase the participants, the geographical location of the participants of their track in their dashboard. And all they need to do is to get the latitude and the longitude of the countries that those people are. And once you plot it into Excel will give you something like what we have here. Where's our Excel control? Okay, to give you something here. So these marked points are the places where our students are based. And then if you overwrite, if it's Excel, it's going to show you like this is maybe Nigeria, some people are from Ghana, and all of that. So that's what your map is going to do for you. Then the last but not the least, you have KPIs in your data set. KPIs is respective to the field you're working with. KPIs means key performance indicators. So it's usually like the most important points that you want people to look at, because now it is easier for me to look at this dashboard and see 6,680. Very simple. Now, to even show further, this person added this icon here for me. So when I look at this thing, even though I don't know what this thing is, I know that the data set I worked with is 6,680. That's what it represents. And then here, the name of this is customer Sean. So Sean means the way that what at which people don't use a product after they use it before, right? For example, you use Spotify this month, you subscribe to their free channel for 3 months. Are you going to return or you are going to churn? If you don't return back, you have churned. So maybe they did this analysis to know how people return after using their product for the first time. So now the data set I worked is 6,608 with that's the number of people that I was able to analyze the data set. And then here I see that we have 26.86% age of people who join maybe every month or depending on the metrics. So what I'm trying to say is that the KPIs, it depends on what you're working with. When I worked with a data set on HIV, you work with CD4 counts, KPIs like viral load, KPIs like uh, the mortality rate of how people die. If you are in finance, maybe you work with simple interests, those key domain things that differentiate industries, right? So they make like in telecom, they work with drop rates, call off rates, handover rates, like success rate of how people are able to connect to their networks. So KPIs are they are subjective to the field in which the data set you're working with comes from. But then they are you must have in your dashboard, right? This so that the most important point people can easily pick it out. Like this one, this is also a KPI. This is a KPI, right? Uh, then this part, you will learn what this part does when you get to Excel. So I think that's for our chats. Do you have any question on chats? If there are no questions, let me ask my own.
Please, I have a question.
Okay.
Okay, my question is, please, I'm still a little bit confused about the difference between the bar chart and the scatter plot, because you said the bar chart shows comparison, then
Yes.
the scatter plot shows relationship.
Yes.
So could you please like throw more light on the both of them?
Okay. So the bar chart and the scatter plot, right? So bar charts, you are trying to compare categories of different things. For example, let's use here. Now, these things, I'm not interested in knowing the relationships. I cannot even infer the relationships between these things from this bar chart. Why? There is no there is no y-axis, there is no x-axis that has values to show me that when this is happening, this is going to happen. I just know that the sales I made for rice is bigger than the sales I made for Gary, and it's bigger than the sales I made for beans. There is no way I am saying I can infer that um if I open shop by 9 a.m., that's why I sold more rice. I'm trying to like use a practical thing to describe it. So the bar chart is just that number. I'm interested in, okay, I sold this quantity, I sold this quantity, I sold this quantity, and I made higher sales in this than this. I don't know whether there's a relationship or not because it's not telling me that. But if you come to scatter plots, there's always a number, there's always a value here, and there's always a value here that you can say that what is happening here, there's a relationship with it here. Then you can also infer that comparison there. So it's doing two things actually. Now, from here, I know that, okay, let's delete this, delete this. Now this becomes a bar chart. Assuming I have this and I rename this person. I rename this person to Uche. Now, this is me, and this is this person. So let's say that these are the different products that we sold. So I can say that Amaka sold higher products than Uchi, right? It's a bar chart. I'm comparing, these are the different products by the same person, rather. This is maybe, okay, let's use employer. This is, both of us are working for the same employer, Amaka and Uchi, right? And then the employer is trying to like rate the number of hours that we worked. So on the attendance, you clock in every
Hello.
day.
Please, you can't see your screen.
Really?
Please. Yes,
I
please.
can see it though. Maybe it's your network.
I am seeing it though. I can see it as well. Please check your network.
Um,
I can see you.
okay. The majority can see it. Can you see it now?
Yes, we can see your screen.
Hmm. Yes, please. It's showing now.
Oh, okay. So you can continue. So they're working for the same employer, and then the employer takes the attendance sheet one morning, decides to check how we get clocking in, and he noticed that Amaka clocked in a higher number of times than me. In that instance, she does not know that like there's no relationship in her mind. She has already just concluded that Amaka is more punctual than Uchi. Like there's no relationship there. She's not even interested in the relationship. So the chat you use is how you want, what you want to answer, the person you want to answer, what they want to do. Like they don't want to show a relationship between this and this. That will determine the chat you're using. Do you get? So for this employer that employs both of us, once she picked up that attendance list, her mind is, I want to know who to sack. And the person I'm going to sack is the person that does not come to work every time. The person that has the higher punctual rates is I'm going to retain the person. Then the other person has to go. And then how do I visualize this thing? The best chart to visualize this thing is my bar charts, because I'm not looking for any other thing. I'm just looking for comparisons. Now, the person that wants to do that relationship, he picks up something and he wants to do a relationship between two things. In his mind, he's now going to scatter plots. I don't know if that answers your question.
Yes, thank you.
So let's go for that. So like I said, you don't have to cram anything. So far you have the foundation, you can always come and ask Google anything. Like maybe you have something you want to represent in mind and you're confused. You can go and type what chart should I use to represent this thing, and to tell you. What I'm saying is that what you have to learn is very broad. What I want to compare again, chart. So if it's in cases, like they usually tell us this thing in cases like when you're doing Python, you cannot cram the whole thing, the whole syntax. You learn classes, you have methods, you have function. So there's no need of cramming, especially in this age. So what you need to do is have a solid foundation. Like today, you have heard of bachelor and scatter plots. If you want to use in the future and you're still confused, you can still come online and ask, then clarify more. Then you see what other persons have used on LinkedIn. Then try to ask, why did you use this instead of this? It's going to like clarify. Then if you read that book I recommended to, it's also going to like tell you more if you're still confused. So that's chat. So let's just do this small thing, and then I think it's answered itself. Sales over time is for what? What do we use?
Line chart.
Okay. Product comparison.
Bar chart.
Market share.
Pie chart.
Okay. Then relationship between two variables. Scatter plots.
Scatter plus.
That's nice. So now let's go back to our guide to know what the covered information. So we've done this. Then there's this part about table too. So sometimes you want to show people the exact figures of something. They call it what they call it? Why you call it table grid, but there's another name for it. So people also draw table on their dashboard, like you see a dashboard, there's a table there. You don't want to use, because sometimes if you use pie charts, it might not get you. It might, you don't want to use visuals. You just want to use a table to like represent some values. Usually there should not be much so that they don't take the larger part of your dashboard. So you can use a table. Table is like table. You draw a table with rows and columns. You just write what you want to write. So we've done that part. So the last part is introduction to data analysis. So when you've learned all of these whole things that you learned so far from lesson one, you learned what is structured data, you learned what is semi-structured, you learned what is a database, you know what is data itself, you've heard the word data, you know what is analysis, you know what is integer, you know what is chart. Now you have built like a very solid foundation to now start using those things together. Because the way you learned it now, you learned it differently. But in real life, you're going to do them simultaneously. After doing this, do this. Right? So this is like the introduction to data analysis. Data analysis is the process of examining data to find useful information, answer, and support. So best of all, you get a data. Data is always in history format. Then do the data analysis process, which we are going to discuss. Then you transform it becomes an information because now information is processed data, right? Then give your insights based on the information you got. So what does a data analyst actually do? First of all, you have to understand the business problem. Now, that is what differentiates you from every other data analyst. That's why you have people who focus on finance. You have people who focus on healthcare. I have my friend that is into economics, like, and that's what will give you a higher power. When people say anybody can transition to data analysis, it's good, it's true. But then that domain knowledge you have, let me break it down. You are a radiographer. I studied computer science and statistics, but I have experience in health and I have experience maybe in telecom. Now, because I've worked in those different places, I understand the business problems there. That's why when you can be able to calculate KPIs, for people that are working in Money Points, the KPIs they are calculating is different from people that are working in UNTH as a nurse and people that are working as a radiographer. So I don't know what you know as a radiographer, and that's your edge over me. So now, when you finish this whole thing, you need to like know the sector that you should work projects on. Maybe the companies you want to work with, you have to go and learn some of their terms because that's what's going to give you an edge over somebody. These days, employers are not just employing you because you know how to do the technical thing. Do you understand their problem? When I went, like the place I went to now, they are doing telecom. First thing they gave me books to read because I have to understand what they are doing first. What problem are they trying to solve? Only after that can I start using their tools to start working. So if there's a problem, I can say this is what happened. So a data analyst, you have to understand the business problem of that domain that you are in. Don't jump from finance today, tomorrow you jump to healthcare. Next tomorrow you're in economics. You are everywhere and you don't understand the problem you're trying to solve. You know how to use it to quite all right, but what problem do you want to solve? You don't know. So you have to define the problem. Now, after defining the problem, you have to collect data that you need to answer it. So collecting data, you can collect primary data. Primary data is like this thing that you share questionnaires and people fill it, right? It's primary because it's collected by you or maybe a research assistant from directly. Now, if it's secondary data, maybe it has been stored before. So like now, I opened this thing. So I wanted to show you the sources where you can collect data from. So there are many places you can get data from. All the data sets here are secondary data sets. because you don't know who collected them. They have been there for some time, so they're secondary. The most popular of them is cargo data sets, right? So if you go to cargo.com, www.cargo.com, you can see a lot of data set that you can work and practice with. Then there is Google data set search, there's Marvin Analytics. All these places, World Health Organizations, Nigerian Bureau of Statistics, NBS. I used to get data there. Then we talk about this Cisco data. So these are the places where you can get data sets from. So as a data analyst, you would collect data. That is at this stage where you're still trying to build your profile. But when you now get employed, the company is going to give you their data sets, the primary data that you work with. But for now that you don't have any company that you're working with, these are the sources where you can get them from. Well, these days you can ask Chat if you are good at Python, ChatGPT can write the code for you, or you can write your code by yourself to generate simulated data that will resemble what you want. So that's another way to generate data. Then after getting that data, clean it and organize it. Cleaning it is making sure that the data is a good data. Because most times data is going to be bad. People are going to be people. Tell people write your name, write it backwards. So you need to clean it. Then you explore and spot patterns. That's when you now start seeing correlations in and trend. So here you now draw conclusions and communicate them clearly using that your dashboard. So these are like the data analysis process. Ask question, what problem am I trying to solve? Collect the data, clean it, explore the data. When you're exploring the data, you look at summaries, the distributions. Like for instance, if it was sorry, I cannot really open that data because it's not my work. So if I was using SPSS to work and I want to like do descriptive analysis, the script analysis you're going to get of them, get their mean, the mode, the interquartile range. Interquartile range is like the minimum and upper threshold between the median. So those are like your exploring the data. Then you analyze it, answer the key questions. So when you're analyzing data sets, actually, there are key questions that must have been given to you to answer. Most times, you generate it by yourself if you are trying to build a project to showcase in your portfolio, right? For instance, I had a data set on health. I like to use health data sets in HIV because I can easily talk about it because I have background there. So if I have a data set from HIV clinic, one of the questions I would want to ask, for instance, there was this analysis I did when US withdrew their foreign aid that they give to Nigeria. And I wanted to know that what effects does this removal have on drug availability? Because US is a major donor. US is a major donor for under US aid for all these HIV-free things because most of the drugs are free. So if they stop, how much impact is it going to have on us in terms of how many people are going to die, how many facilities are going to stop having drugs? So these are the questions now I want to answer from that data. And then I start answering them. Now, you now visualize and communicate using those charts and the dashboard that we talked about. So I think that is the end of our session for this. Before we round off, let's talk about types of analysis that I do. There are 4 levels: descriptive, diagnostic, predictive, and prescriptive. And the type of analysis you do is dependent on what problem you're trying to solve. If your stakeholder told you, asked you a question, why are sales going down? You are doing a diagnostic analysis because you want to know the reason behind what happened. What happened, past tense. So that has happened. Now, summarize past data to describe it So prescriptive and diagnostic, they go hand in hand because you have to know what happened and then maybe find out why it happened. So what happened? Descriptive. I'm trying to describe that sales are going down. Why did it happen? Because there's no adverts. Now, predictive, based on past data, you want to know what's going to happen in the future. Forecast what is happening. If this thing continues like this, if rain keeps falling every day, that means people are not going to sell markets and hunger is going to kill people. They are predicting. And that's why people are able to forecast the weather because there isn't past data. Rain fell on June 12th, 2024. It fell at this time. It fell on June 12th, 2013 at this time. So it's likely to happen on June 12th, 2027. And predicting based on the historical data that you already have. So it's predictive. Then prescriptive is like they're recommending um recommendations, and that is very important. At every time when you use analysis, please try to always prescribe or invent solutions to the problem that you found out. So at this junction, I want to tell you that you should ask any questions that are done with introduction to the analysis. So like I said, everything you learned in this introductory phase, let's be applied across the different tools you use: Excel, SQL, SPSS, Power BI, Python, name it. So it's good that you grab the information that's asked. If you have questions, you can ask me. Any questions?
Yeah, thank you very much, Loretta, for this insightful session. I mean, thank you very much. And do we have questions? Do we have questions? If you have questions, you can unmute and ask your question. And oh, there's a whole lot of hearts and hand clap. I think my thank you is not doing justice enough. Thank you very much, Loretta. This is actually a very insightful session. And despite your schedules and the whole troops you have to run over to be here, and we're not taking it for granted at all. Yeah, you can unmute and ask your question, or you can drop it in the chat box.
Okay, please have a question.
My,
But I have a question.
Yes, go on.
Okay, before I go ahead, thank you so much, ma, for the teaching. At least you really simplified a lot of things. Okay, my question is this, because on the flyer, it's shown that you're a data engineer, but then you're teaching us this. So is it possible for somebody to be both a data analyst and a data engineer at the same time?
Yes, it's possible. So you have to start somewhere, right? Data engineering is a more technical role than data analysis. And you have to start somewhere actually. So this I started off as a data analyst. Then when I thought that I've grabbed what I want to grab, because you can't know everything, right? When I thought I've grabbed what I want to grab, I transitioned to data engineering. So sorry, give me a minute.
Yes, yes, all right.
So when I thought that I grabbed down to grab a data analyst, I felt like it's time for me to move. So yeah, that's why I did engineering. So yes, you can still take on, since you know it already, you can take up roles in data analysis. If you can handle the tasks, like the work that comes with being both, you can pick up different things.
All right, thank you.
Okay, is that all?
Do we still have questions? Do you still have questions?
Larissa, thank you very much for your presentation. It's quite educative. Mine is not a question, but I would want to request if this recording can be uploaded so that we go through it again and so that we'll be able to retain some of these things that you've actually put us through. Because to be very sincere, if one does not go through this recording again as soon as possible, the tendency to, to forget most of the things that has been said, especially in today's class, uh, will be there. So I would really appreciate if the recording is uploaded as soon as possible so that we can go over it again. And maybe in the next class, we might now have more questions on that particular topic to ask. Thank you.
All right. I know that this is presented that.
Yeah, so we're working on the recordings, right? It's supposed to be up by the end of today, but we had a glitch on our YouTube channel. And so what's going to happen is if we can't get it up by the end of tomorrow, we are going to share the link to the Google Drive. Then it means that people will now have to download it individually.
Okay, sir. Please, what about yesterday's own? Is it up or I think same refers to yesterday's own because let's be building up
Yes,
together.
yes. So I'm not Sal. My name is Chijike. So what I'm saying is still the same thing. That all the sessions that we've had, not just in this track, every other track, right, is supposed to be up by the end of tomorrow. If it's not up on our YouTube channel by the end of tomorrow, we would have to now send individual links to them. Then you have to now download it yourself.
All right, thank you very much. Okay, please permit me to say this. I think you've just said this about this, and I think Miss Loretta said something like that. I believe I'm kind of a senior person here. I just want to believe this. Whenever you are in charge, you are a sir or a ma. It's just people according you the respect you bear in that scenario. Please let's learn to accept it. It's just an honor, not like you are. I don't know. Just know that it's courtesy. Okay, thank you.
All right.
Okay, ma. Correction taken, ma.
I've accepted it.
Yeah. So once I just want to say quickly before we end the call. Sorry, let me just stop the recording before I say what I want to say.